So in this example, we have f of x equals 2 over x minus 2 and then plus 3. So it's going to be very similar to what we did in the last example. So let's start identifying our horizontal asymptote. And I mentioned that the horizontal asymptote is going to be related to the number that's after the fraction, the plus 3. So since we have plus 3 after the fraction, our horizontal asymptote will be y equals to 3. Now let's take a look at our vertical asymptote. So vertical asymptote is going to be related to what we have in the denominator. Since the fraction is in its simplest form, so I'm going to set our denominator factor with the variable x minus 2 equal to 0. I'm going to add 2 to both sides. So here we're going to have x equals to 2. That's going to be our vertical asymptote. Now let's focus on finding the intercept. I'm going to do the y-intercept because that's going to be the easier part. So y-intercept is going to be plugging in 0 for x. So we're going to have 2 over 0 minus 2 and then plus 3. So I'm going to simplify the fraction. For the denominator, 0 minus 2 will be negative 2 and then plus 3. And my numerator stays the same. So I'm going to continue simplifying the fraction. 2 divided by negative 2, that will be negative 1 and then plus 3, which will equal to 2. So therefore my y-intercept is going to be 0, 2. So that's my y-intercept. And then I'm going to write my information over here so I can have room to do my x-intercept. So y-intercept 0, 2. Alright, let's do the x-intercept. So for the x-intercept, we send the whole equation, the whole function equal to 0. So 0 equal 2 over x minus 2 and then plus 3. So what I'm going to do first is I'm going to add, I want to get rid of this plus 3. So since it's not part of the fraction, that's the first thing you're going to get rid of. So I'm going to subtract 3 to both sides. So we're going to have negative 3 equal 2 over x minus 2. And just like before, I'm going to multiply both sides by the denominator so that I don't have any more fraction. So right side multiply by x minus 2, left side multiply by x minus 2. Now for the left side, I'm going to distribute my negative 3. So I'm putting the negative 3 in parentheses since I'm multiplying to the x, multiplying to the negative 2. Now be very careful. If it's a negative number, make sure that you put in parentheses so that you can clearly see that you are multiplying. So negative 3 times x, so negative 3x. Negative 3 times negative 2 will be plus 6 equal. So for the fraction, if I'm multiplying by the denominator, these two will divide into 1 and I'm left with 2. So I'm going to write over here for more space. So negative 3x plus 6 equal to 2. So when I'm solving for x, I'm going to cancel out the 6. So minus 6 on both sides. So it's going to be negative 3x equal 2 minus 6 will be negative 4. Then I'm going to divide both sides by negative 3. So it's going to be x equal negative 4 divided by negative 3 will be positive 4 over 3. So my coordinate point will be 4 over 3, 0. That's my x-intercept. So what I'm going to do is I'm going to write my information for the x-intercept over here so that I can have more room when I'm identifying transformation and domain and range. So my x-intercept is 4/3 or 4 over 3, 0. Now you can convert 4 over 3 into a decimal, which will be 1.33, 0. Alright, so let me erase so that I can make room for transformation and domain range. So since we have on the x the -2, any number with the x will be left or right. So in this case, since it's x -2, it's going to move right 2 units. Now, for the +3, since there's a number after the fraction, it's going to go up or down. But in this case, for +3, it's going to move up 3 units. So that's the only transformation we have for this example. Now let's talk about domain range. So I'm going to label D for domain. And I mentioned before that it's going to be all real numbers except for what we have at our vertical asymptote. So I'm going to say all reals except my vertical asymptote, which is the 2. And then for the range, which I'm going to label as R, it's going to be all real numbers except for the number at my horizontal asymptote. So I'm going to write all reals except 3. So there goes my asymptotes, my intercepts, my transformation, and my domain range. And again, if you study the work and what I wrote for asymptote, intercepts, well, mainly the transformation and the domain range, you can see a pattern related to the function, the given function or given equation. Next, I'm going to use the asymptote and intercepts to help graph. So for the graphing part, I label my horizontal vertical asymptote, my x-intercept, and my y-intercepts. So let's start labeling our horizontal asymptote. So y equals 3, so that's going to be above 1, 2, 3. So here's our horizontal asymptote. Alright, let's take a look at our vertical asymptote. X equals to 2, so it's going to be towards the right at 2, so 1, 2. Here's my vertical asymptote. Alrighty, so let's start labeling our x-intercept. Our x-intercept is going to be 1.33, 0. So 1.33, that's going to be between 1 and 2, and it's going to be very close to 1. So I'm going to mark right here on the x-intercept, the x-axis, where you kind of can see that it's close to 1. And let me zoom in for you to closely examine. Now next, I'm going to label my y-intercept where it's going to be 0, 2. So 0, 2, which is right here. So I label my 2 points. That means that the graph has to go through these 2 points. So I want to start at my vertical asymptote because the point right here, my x-intercept, is very close to the x-axis. So I'm going to go along the vertical asymptote like this, go through the x-intercept, curving towards the y-intercept, and as I'm approaching the horizontal asymptote, I'm going to continue curving and just go along the horizontal asymptote. So here's my graph. So let me zoom out for you to easily see the whole picture. Now, once we establish that the graph is at the bottom left, then it's going to be diagonally across, so it's going to be at the bottom right. So I'm going to use the vertical asymptote to guide me, and then I'm going to curve towards the horizontal asymptote and use that to guide me also for the bottom part. So there's my graph for the top right. And again, for reciprocal function that the graphs are always going to be diagonally across from each other. So there we go for our graph with this example.